Okay, so today we're going to start with chapter number 4, okay, which is making decisions. These are the topics that we're going to be working with: relational operators. We're going to go into the if statement, 3 different if statements: the if, the simple if, the if else, the if else if. Also, we're going to be implementing this menu-driven programs using the ifs. We're also going to be working with nested ifs. Nested means one inside another. We're going to be working with logical operators, not only with relational operators, but also logical operators like the and, the not, the or. We're going to be using the if statement to validate user input. Remember that we already talked about blocks, the curly braces, how we can set up a block. Like in main, we start main curly brace and then we close it after the return. Well, we're going to be implementing more blocks, and of course this is going to be affecting the lifespan of the variable, so that's the scope. We're going to continue working with characters and strings with a different application of the if, which is called the conditional operator, with the switch statement that is going to allow us to take different actions. And we're going to be introduced to enumerated data types. So this is what we're going to be doing in chapter number 4. So to start, we need to identify the relational operators. If you remember when we discussed CPU, one of the areas that we have been using is the arithmetic and the logic unit. So in the arithmetic unit, we know that this is where all the mathematical operations take place. RAM does not add, subtract, divide, multiply. Everything like that is done in the A and L unit. Well, the relational operators are going to help us now solve equations that are going to be giving us only 2 answers, true or false. So these relational operators are going to be solved in the arithmetic and the logic unit as well. So we're going to be using these operators not to add, subtract, multiply, divide, or find a modulus, but to compare. So we know that when we compare, when we make a question, we can have 2 answers, yes or no, true and false. So that's all the answer that we're going to get from the A and L unit. Okay? So used to compare numeric values to determine a relative order. These are the operators, and I'm sure you're already familiar with them. This is the greater than symbol, less than symbol, a combination of greater than or equal to, less than or equal to, the equal to. Look at this. It has 2 equal to signs. This is different from our assignment operator. Remember, the assignment operator only has 1. So if I want to ask a question that has like, is GPA equal to 5 or to 4, then I'm going to be using the double equal sign.
To check?
Yes, this is to compare it, to check. Okay? And if I want to say not equal to, then I have to use the exclamation mark together with the equal to sign. Okay, so this is just a word of caution, because sometimes we make this mistake, programmers make this mistake very often. Instead of using 2 equal signs, they only use 1. And remember, if we use just 1 equal sign, this is not an equal to symbol, is the assignment operator. So we have these relational operators that we're going to be using when we create these expressions that are going to be comparing. So relational expressions are Boolean. Boolean, remember, only has 2 answers, true or false, yes or no. And this is an example. Is 12 greater than 5? So the answer here is true. Is 7 less than or equal to 5? This is false. If x is a 10, then we're using x as a variable. Then we're going to be comparing, is x equal to 10? Well, this is true. It's x less than or equal to 8? This is false. It's x not equal to 8? This is true. It's x equals to 8? This is false. So as you can see, the only answer that we have here is going to be either true or false. That's all we have. So again, these are our relational operators, and when we use them in an expression and the expression is evaluated, it's solved in the arithmetic and logic unit, the answer is going to be a Boolean answer. True or false? Yes or no? Now, the relational expressions, one of the application is I can make it as if it was an arithmetic expression. I can use it in an assignment operator. What am I doing here? What I'm saying is x less than or equal to y? So the result of this expression that is going to be evaluated in the arithmetic and logic unit is going to be placed in the variable result. And result, it's a Boolean type variable. So here is going to have either a yes or a no. The result of this is going to be, if it's false, is going to be a 0. If it's 1, is going to be true. So let's suppose that x is a 5 and y is a 7. What am I going to get in result after the expression is executed? True, which is going to be a 1, right? Okay, let's suppose that x is a 100 and y is a 50. What am I going to get in result after the expression? 0, because it says false, right? So again, this is the assignment operator right here, and I'm going to be evaluating this part first. The result is going to move to the variable that is to the left of the equal sign, or the assignment operator. Now, we're going to be implementing these expressions in the if statement. The if statement supports the use of a decision structure, allows statements to be conditionally executed or skip over. This is very important. Up to now, we have been coding programs where every single line it's executed. We have declared variables. We have used the variables with cin. We have asked the user to interactively give us the values in those variables, and then we have applied those variables in our expressions, in our arithmetic expressions, and then we have been sending those results to the output with the cout. And every single instruction in our program has been executed. Now, we're going to be able to tell the computer, hey, skip this part. Like if I ask you, okay, if you pass the class, you will be able to take PF2. If you don't pass the class, you will not be able to take PF2. So the question here, am I passing the class? You're going to have two alternatives, right? Two paths. One is take PF2, the other one is going to be skip PF2. Right? So this is what we're going to be telling the computer to do, okay? Using, of course, our instructions. So we're going to be able to conditionally execute X number of instructions, or we're going to be able to skip over X number of instructions. Here they have an example. If it's cold outside, wear a coat and wear a hat. But if the answer to this is false, then we're going to skip this part. We're not going to be taking a coat. We're not going to be wearing a hat. So we're going to be able to select which instructions we are going to be executing and which ones we're going to be skipping, depending on the answer of the expression. How are we going to do this? Here is our statement. We have if. In parentheses, we're going to be stating the condition. Okay. In parentheses, we're going to be stating the condition. So we're going to put here x greater than 5 or GPA less than 2.5, etc., etc. All the conditions are going to be here. The questions will go here, and they have to be surrounded by parentheses. Then we have the curly braces. This indicates, okay, everything that is here within this curly braces is going to be executed only and only if the answer to this question is true. So we need to make sure that we have that. Only if the answer to this condition is true, the computer is going to execute these statements. So if I was going to write this question in here, then I will put here if whether it's equal to, so I use the to equal sign code, then in the curly braces I will put wear a coat, wear a hat. So I'm going to be putting this. If the condition, the result of the condition is false, then everything that we have in this block is going to be skipped. We call this block the body of the if. We have one option. If there's only one statement, we can skip the curly braces. But if we have more than one, we have to use the curly braces. I'm going to ask you to always use the curly braces, even if it's only one statement, just so that we can visualize the body of the if. Later on, if we decide to drop the curly braces, if we have just one statement, we will do that. But for right now, for this couple of weeks, we're going to be using the curly braces. This is how it works. This is just a summary of what I explained. If the condition is true, then the statements in the body are executed. If the condition is false, then the statements are going to be skipped. This is a graphical representation of the if. So we have here a condition. If it's true, we're going to be doing one or more statements and then continue with the execution. If it's false, then we're going to be skipping the body of the if. So we can write here, if final grade for PF1 it's 70 or greater, then I'm going to be taking PF2. If final grade for PF1 is greater than 70 and this result is false, then we're going to skip and we're going to continue here, right, with whatever other class you can take. I hope this example helps. Okay, here's just a couple more examples. Here they don't use the curly braces, but remember we're going to try to use them. This is one line. So they are checking here if score is greater than or equal to 60. Okay, remember this is going to be solved in the arithmetic and logic unit, and this is going to give us an answer, true or false. Let's suppose that scores is 70. This is going to be true, so we're going to send a message saying you passed, and then end of the line. If score is greater than or equal to 90, we're going to assume that this is a 91. We're going to be putting A in grade, and we're going to be sending this message, wonderful job, and we're going to end the line. Yes? If it was 92, it will give you an A in grade. If it's a wonderful job, we'll put it in the console out. Yes, yes, yes. If we have these 2 lines, consecutive lines, then it's going to be 92 greater than 60, yes, you pass. 92 greater than 90, put an A into grade, and then send this wonderful job as well. So we're going to get 2 lines, yes. If it was less than 60, this is not going to come out, right? If it's less than 90, this is not going to come out.
Are they both going to show up or just the bottom one?
Depending what is the value of score.
Let's say if it was 90, would also not the bottom?
Yes, if we start here with the value of score is assign the value of 90. Let me just open this up so that I can put it here. Okay. Okay, let's suppose that we have in score. This is the assign the value of a 91. Okay, and we have 2 consecutive ifs. The first one is score greater than or equal to 60? Yes. So we're going to do this part. So this is going to be displayed on the screen. You pass. Then it goes to the next line, and it's going to ask, is score greater than or equal to 90? Yes. So A, this happens inside RAM, okay? But then this one is going to be sent to the output. So we're going to get wonderful job. So at the end, we're going to have 2 lines. Did I answer your question? Okay. So again, here are some notes. If it's a keyword, so we have to, it must be in lowercase letters. The condition has to be surrounded by parentheses. We do not place a semicolon after the condition. The end is going to be given by the curly brace. Right here. The end of the statement is going to be given by the curly brace when there is more than one statement. If we omit the statements, then the first one is going to have the semicolon, and that is going to indicate the end. Some recommendations, and this is just our recommendations. Remember, this is just a recommendation that they do for all programmers. Place each statement on a separate line after the condition. Indent each statement in the body, and this is so that we can read it. Use curly braces around the body, put open and close on lines by themselves. Okay, do not add anything to that line. Okay, this is just so that we remember what is true and what is false. An expression whose value is 0 is considered false. An expression whose value is non-zero is considered true. So the Boolean is going to be 0 and 1, but we can have also different values that is going to be accepted, and it's always going to be true. Something that we're also going to be using, and this is just a term, it's a flag. A flag is going to give us go and stop, or red and green. A variable that signals a condition usually is implemented by a Boolean result. So meaning true, the condition exists, false, the condition does not exist. Like I have a flag. I have the green flag, that means go, you can run. I have the red flag, that means stop. The flag value can be both set and tested with if statements. So we're going to be creating flags. This is an example of a flag. I have here valid months, and we're going to put a flag. This is going to be true. So now we're going to have a 1 invalid month. Then I have a condition. If months is less than 0 months, let's suppose that this was given by the user and they put a -1. So then invalid months, we're going to say, hey, this is false. So we're going to change this. Instead of 1, we're going to have a 0 now. And then I'm going to test it. Here, I don't need to use the equal to, this symbol. Here it's testing it, if it's true. If it's true, calculate the monthly payment. So this will be a go. Okay. Monthly payment is going to be assigned the value of total divided by months, because I know that months has a valid value, not less than 0. So here's an example of the flag. Integer variables, any integer value variable can be used as a flag. Remember that 0 means false, any other value means true. So here's again an example. We have here int, all done is set to 0, which is false. And I'm going to ask here, count. Count has a variable, and we already gave some value to it. The same thing as maximum students. It's a constant, so it was already assigned a value to it. So we're checking this too. Is count greater than maximum students? We're putting 1 to all done. We're finished. If all done is true, remember, is true means 1 or any other number, then we're going to send task finished. So again, we don't need the equal to here. If we're going to be testing an integer variable that is set as a flag, or a Boolean variable that is set as a flag, we don't need the equal to. It's always going to be testing for true. In this case, valid months, is this true? Then we're going to be doing this. Valid months, is it false? We're going to be skipping this part. Okay, so we're going to stop right here, and we're going to implement this. Questions before we start? We're going to open Word. And we're going to create a program where we ask the user for the class final grade, and we're just going to send a message, a simple message. If the grade, we're going to write here the description of the program. This program asks the user to input the final grade for the class. If the grade is greater than or equal to 70, a passing message will be displayed. Okay? So In our output, what we're going to have is we're going to be asking the user, enter your final grade, right? And then a message, you passed the class, or no message, right? Okay, everybody with me? So this is a very small program where we're going to be implementing our if. So we're going to be asking the user, enter your final grade. The user is going to be typing the grade, and then based on this grade that we receive, we are going to send this message: you passed the class, or no message. If there is no message on the screen, the user is just going to be blinking, right? Trying to understand what happened. But we're not going to say anything. Let the user suffer for not passing the class. Okay, so we're ready to start pseudocode. So what will be step number 1? Okay, so memory allocations, our variables and our constants if we need them. Okay, what variables do we need, or what constants do we need? Okay, we need a constant of 70 because that's our passing grade, right? So constant, we can put here passing grade. I'm going to put it in capital so that I remember. And this is going to have a value of 70, right? Okay. Do we need variables? Okay, a variable that the user inputs, which is, can we call it final grade? I think that's it. So now step number 2. I already have a constant and I already have a variable that I'm going to be using. Now, what am I going to be doing with this constant and with this variable? Boolean. Compare. What do I compare? The final grade with the passing grade. Do I compare that? Yes, I have a yes. Okay. But what is final grade? Do I have something in final grade? I need to ask the user before I can compare, right? So step number 2 is, well, let's ask the user so that we can have something in final grade. I have something in passing grade already, which is a 70, but final grade is empty. So let's ask the user to input the final grade. Okay? So now that I have it there, what am I going to do? Compare now. My comparison is going to be if what? If, okay, if final grade is greater than, I'm going to put it in words. Is greater than or equal to 70. We have it here on the top. Or equal to 70, I have it in passing grade, right? What am I going to do if this is true? Then send a message. You pass the class. And then I finish my program. End of program. Questions about this pseudocode? So now we're ready to implement, to code our program. We already know what we're doing. We analyzed this. We came out with an output design. We have our pseudocode. So we're ready to start our program. So we open up Visual Studio. We're going to start a new project. It's going to be Win32 console application. We're going to call this grade. Click on the OK. Go to Next. Make sure that we select Empty Project. Finish this. And we're going to add the code. Code, C++, grade. Okay, we're going to put our pseudocode here next to our coding window. So here we have it. Okay, so we start our project by documenting what this is about. And we already have it here, right? So I'm just going to copy this. We're going to set up, also we're going to be documenting the date. So it's October 20th, 2015. And this is our class. All right. We can also use the slash and the asterisk, right? We have multiple lines, so I can set this one up like this. Omit these lines right here. Omit these lines and close my comment paragraph with this. So we can either start each line with a double slash or use slash asterisk to begin the multiple line comment and then close it with asterisk and the slash. So based on the pseudocode and all our analysis, how many includes do you think we need? 2? Which are? Let me start. IOStream, okay. Do I need another one? Yes? String, am I going to be asking for name or address or things like that? No. I'm not asking for the student name. That's it. That's all we need. So we close it using namespace, std, semicolon. So we're ready to start main. int main, open and close parentheses, and I start now my first set of curly braces, which is my main block. This is the main block that we're going to have. So now, following my pseudocode, I'm going to put memory allocations, variable and constants. Okay, so I'm going to document this part. Variables and constants definition. Okay, so you told me that we were going to need 2. One constant. How do we start the declaration of a constant? const. Then a name is passing underscore grade, and then I give it a value. Assignment operator 70, and then I close my statement with a semicolon. What am I missing here? Because it's giving me a problem. The lowercase, no, because this is a constant, so they recommend that we use uppercase.
Constant int or no?
The data type is missing. So I need to say, what type of data is this? Is it a whole number? Is it a real number? What type? It's a whole number. So whole numbers, I can choose short, int, or long. Which one do you want to? Int. Okay, so I have to use constant int and then passing grade, assign the value of 70. So now there are no errors. Okay, the next line is I need to define a variable that is called final grade. So how do I start the variable definition? int, why int? It's going to be a whole number, okay? Final grade. And I don't need to initialize this one. I don't need to start with any value because the user is going to give me the value for this. So we have that. And then this is going to be ask the user to input the final grade. So this is my input. Okay, how do I ask the user to input? A cout, because we have to prompt. I have it here, right? So we're going to put cout What is the name of this operator? Output stream operator. Remember, if it's Cout, well, the name of the operator is output. Stream, it's always going to be a stream operator. And we're going to write here, enter your final grade. Leave a couple of spaces. Close the quote. And then we want the cursor to be right next. So we're not going to put end line here. Now, how do I get the cursor to blink there so that I can get the answer from the user? CIN. Then what is the name of this operator? Input stream operator. And where am I going to be placing the value that the user types in?
Final grade.
Final grade. Okay, and then my process. Process doesn't mean that I have to add, subtract, multiply, or divide. It also means what? Comparison, and that's what we're going to be doing. So what am I going to compare?
If the grade is greater than or equal.
If which grade?
The final grade.
The final grade is greater than or equal to what?
70.
To 70. Okay, so I'm going to put here, how do I compare using C++? If, then,
If the grade.
go to the PowerPoint presentation.
Final grade. Final grade.
If this is the format, what do I need to use? What are things? Very good, very good. We're getting there, but what do we call things? Parentheses, right? So I have to use if and then the parentheses and the question goes inside. So I'm going, if, open parentheses, the question you already gave it to me, and it's what? Final grade. How do I put greater than or equal to?
The, yeah.
Yes, which one is it?
Greater than.
This one? No. Okay, pointing to the right. Greater than, and then right next to it, the equal sign. Final grade greater than or equal to passing grade, right? Underscore grade. If this is true, now we have another set of curly braces. What do we want to do? A message. How do we send a message to the screen? Cout. Cout. Then the, what is this symbol called? Output stream operator. Okay? And what is the message? You passed the class. We want to add an end line. And that's it. Yes.
On the first thing, are you gonna end line? Not
Where? Enter your final grade? No, I said no because I want the input to be right next to this. No, I don't want to do the entering on the next line. And this is it, right? My next line is going to be return 0. And this is the end of main. Okay, before we run it, let's analyze main one more time. In main, the first thing that we did was we created a constant that is an int, and is going to be assigned the value of 70. And the name of this is passing underscore grade. Where did I miss?
Constant. Variables and constants.
There we go. Thank you. Then the second thing that we did was we created a variable that is called final grade. Both of them are ints. So that means I'm restricting the data that we're going to be placing in constant and variable to be only whole numbers. If we or the user tries to put a value that has a decimal portion, it's going to be truncated. Then we're sending a message. Enter your final grade. We're leaving some spaces, and then right next to the message, we're going to be accepting the value that the user types in. This value is going to be stored in RAM in a variable called final grade. So we already have something in final grade, and we already have something in passing grade. Then we're comparing here. We're asking if final grade, which is whatever value the user gives us, is greater than or equal to passing grade, which we already set up to 70. If this is true, we're going to be sending this message. If the answer to this question is false, then we're going to be skipping this line, and we're going to close the program. Questions before we run this program? Okay, then we're ready to run it. So we're going to use Control 5 for that. Yes? And we have here, enter your final grade. Let's put a 60. Press enter. Do we get a message? No. No message. Okay? Now we do it again. Control F5. Enter your final grade. This time we're going to put a 90. Press enter key. You pass the class. And press any key to continue. Okay, we're going to run it again. Enter your final grade. We're going to type a 70. Press enter key. You pass the class. So anything 70 or above is going to be your pass the class. Anything below 70 is going to be no message. Questions? So we already implemented the simple if statement in our program. If the grade is 70 or above, we're sending a message saying you passed the class. But if the user types a grade less than a 70, 69, 68, 50, etc., then there's no message. So we leave the user blank, not knowing what happened. The user is going to think that he or she passed the class, but just that the system is not doing what it's supposed to. So we don't want to do that. So we're going to be adding now another if statement. And this is called the if-else statement. So the first one is the simple if, just if, where we can either go into the body of the loop in body of the if or skip. This one, if the if else, is going to give us two actions. It allows a choice between statements depending on whether the condition is true or false. So this is our format. We're going to start if, in parenthesis, condition, curly brace, statements here if it's true. Right here it's going to be if it's true. Statements here if it's false. So we have to remember, if the result of this condition is true, this is the set of statements that are going to be executed. If the result of this condition is false, then this is the set of statements that are going to be executed. And we're going to be adding a keyword, that is the else keyword, that is going to be in between. In between. So in our example, it will be if final grade is greater than or equal to 70. If it's yes, if it's true, we're going to be sending you pass the class. If it's false, then we're going to be sending you failed the class. So let's see what else. Here it is, the summary of what I just explained. This is a graphical representation. So we test the condition. If it's true, statements in set 1 are executed and never statements in set 2, and the other way around. If condition is false, statements in set 2 are executed, but statements in set 1 never are executed. So it's just going to take one or the other route, but never both routes. So let's see. Let's go back to our program. So we're going to change first our pseudocode. The program asks the user to input the final grade for the class. If the grade is greater than or equal to 0, a passing message will be displayed. If the grade is not greater than or equal to 70, a failing message will be displayed. So here we're going to put you pass the class or you fail the class. One or the other, but not both, right? So now in my pseudocode, I'm still going to have my constant. I'm still going to have my variable. I'm still going to ask the user to input the final grade. But now this is going to change. If final grade is greater than or equal to passing grade, then send a message. You passed your class. Otherwise, send the message. You failed the class. End of the program. So we have everything. We just need to implement this if. Now the new if. I leave my variables as they are. I leave my input as it is. And now here in my process, what do I need to do? Excuse me? Add another line that is going to have else. and then open up another set of curly braces. This is another block. And what am I going to get in there? See out. You failed the class. End of line, semicolon. Control F5 now. Okay, we have here, enter your final grade. We're going to put a 60. Remember, when I was testing this program, I used a 60 and we didn't get any message. Now, I use a 60, enter, and we have a message. You failed the class. Okay, nothing else. Control F5 again, enter grade. We're going to put a 75. Press the enter key, and it's giving me, you passed the class. So it's giving me one or the other, but not both. And that's exactly what we want, right? Questions?